All right, so we are now going to look at a different type of example where we want to find the data value at a given percentile of a data set. And so before we start, I need to introduce a key step. So the key step for this type of problem is to calculate a what's so-called a locator. So the formula of the locator is here, given L equals, L stands for the locator, and L equals P over 100 multiplied with N. So P here is the given percentile value, meaning, so imagine this type of problem is that we already had a known percentile. Let's say we want to find out which value in the data has the given P% of data of other data values falling below it. So this is what the type of problem is for. And so the idea of the locator is that we're gonna need to locate within our data set to find out which position, which data value at which position, at which location. That's gonna be satisfying that high P% of data falling below. And so let's go ahead and start it into one example. So the type of example we're doing here, and let's say we're going to want to find a P percentile. And so in my example, let's find the 23rd percentile of data 1. And so data 1, as you're looking at it, 23rd percentile in here is indicating that from where our value stands, it's going to have 23% of data below it. So some development about the problem, but we know that we're going to have 23% of data values below this. Below this value, and normally, like I said, in the definition, we call this the cutting value. All right, and so therefore, we're going to look for the locator. So the locator, as given in the formula, 23% is going to be my P number, and divided by 100. Multiplied by 40. So my locator here turns out to be 9.2. So notice that this locator here, coming right out from the calculation through the formula, then this locator here turns immediately into a decimal. So the locator we have here runs into a decimal, which is a lot of time normal out there. A formula set up like this, a lot of time it can give a decimal calculation, and then on the other time, some other times it's going to give a whole value. And so in our case here in particular, we ran into a decimal locator. And so once again, as I said, the idea of the locator is to locate which position your data value is in the data set. And so for that reason, if you think a little further about this decimal locator, then it must be rounded to a whole value. And so now, so for that reason, the rule to round now is that when your locator is a decimal like this, we are going to round L to the nearest whole value above. So two requirements. We need to round. We round to the nearest whole value, and being above what it's currently be. And for that reason, I am going to round my locator to 10, which is the nearest whole value above. So now once I've updated my locator to come to the final whole value above locator right here, then my percentile, my 23rd percentile is ready to be found. So my final conclusion now is the 23rd percentile is equals to my 10th value on the list. So notice this 10th right here came out because of what the locator was indicating. And so the 23rd percentile came out to be, the value of the 23rd percentile came out to be the 10th value on my list, which is the value 68 right in my data 1. And that's how we found the value of my 23rd percentile of data 1. And now, in a different example, we are going to find the 25th percentile of data 1. And so, having some experience through the previous example here, then once again, I am going to look for the locator. The idea once again here is that we need to find the cut where 25% of data value fall below this cut. And that's just straight out of the definition of a percentile. This cutting value in the data 1. And so in that understanding, then my locator is to be the first key step to come out right here. 25% of data falling below that cut out of 100. I am going to multiply that with 40. And this time, easy enough that the math can quickly turn out to be 10 immediately. And so this time, unlike the other example, immediately right after the calculation through the formula, then our locator turned into a whole value already, which consequently we don't need to round. So there's no need for rounding this locator. However, it does take into a slightly different route to find the final value that satisfies this locator here. So my answer here for this 25th percentile, here's my argument. The 25th percentile in this case, keep in mind, we didn't need to round. So the 25th percentile in this case, I'm going to look for the 10th value on my list, which makes sense, the locator told me. But I also need to find the 11th one, which is the one immediately following the 10th. Add up the two values, divided by 2. And in that case, back into the data 1 right here, then we're looking at 68 as being our 10th value. The 11th value is another 68. These two values being added together and divided by 2. And that comes to our final answer. Our final answer for being the 25th percentile is 68. And so the bottom line now, after working through a couple examples here, then back to a general method finding the data value that at a given percentile, then the first key step has always been we need to look for the locator, and the formula is given as indicated here. And then what we have seen through our couple of examples here was that when your locator L value is a decimal, then we need to round L to the nearest whole value above. Then making our conclusion that the P percentile is going to be simply that value at the Lth position on the data list. So notice that doing your work this way when the locator was a decimal, then make sure these steps here are sequential. You must round the L value first, the locator value first. Then look for your p percentiles based on the updated locator. In the other case that we have seen, now when L turns out being a whole number, then what we need to do now is we're going to look directly for the Lth positions on the list of your data, and also look for the next one, which is namely or symbolically here I call it x L sub L plus 1, x sub L plus 1. And then we're going to calculate our final p percentile by doing x of L plus x of L plus 1 over 2. So we add up the two consecutive values, the two adjacent values, and divide it by 2. And so after you have spent some time looking at the examples, how we found the values at given percentiles, then here's a little work problem that I want everybody to have a try right here. So why don't you find for me the 50th percentile. And as soon as I finish writing down the problem, you can go ahead and pause the video and start working through your steps. And make sure you document your step carefully. And once you finish and came up with your final 50th percentile, indicating once again which value in the data set, data 1, has 50% of data falling below that. All right. And so I hope that everyone has spent some amount of time looking for the 50th percentile of data 1. So I'm sure you found your locator to be 20. And I am sure that you didn't need to round. So this is just simply straight out from the calculation. It was a whole value. We didn't have to round. Then consequently, at this point, you made your conclusion saying that the 50th percentile was the 20th value on the data, which was, or I can just simply write it down one more time, and the 21st value over 2. And that gave me 72 and 76 added up divided by 2. So our 50th percentile was 74. I am going to ask everybody again to find for me the 75th percentile right here in this video. Find the 75th percentile of data 1. So you can now pause the video and let's start working on that. Okay, so now you're back. So I hope you agree with me that the locator for this percentile should be 30. And once again, here is another problem. We found that this locator was by itself, right after the calculation, was a whole value. We didn't have to round, so no rounding. And you already had an idea of what to do. So that 75th percentile concluded to be, we look for the 30th value on the list, and we look for the 31st value on the list, add up the two values and divide by 2. And so my 30th value on the list was 80, and my 31st value on the list is another 80. We add the two values, divide by 2. So now we come to that conclusion, saying that our 75th percentile was at value 80. And so now that you have seen quite a few examples, finding different values at different given percentiles, then let's particularly focus at those special percentile. First of all, let's look at that 50th percentile. Let's find out what's special, what's a little more special about this 50th percentile. It's not only in this data one, but also generally in other data sets. What's 50th percentile mean to a data set? Now, first of all, remember right in the beginning definition, I was saying any percentile is a cutting value where that many percent or that high percentage of data values falling below it. We have actually seen this terminology, the cutting value, a little while ago. So at this percentile, there are 50% of data falling below that. So what we just now found is that what makes the connection here is that the 50th percentile turns out to be exactly the median of the data. So now I would say 50th percentile in general for any data, aka also known as the median of the data. And to quickly verify that with you, with everybody, I can just have you have a closer look back into the work that we found, the 50th percentile, but I'm sure you found your locator was 20. And so what we did here was we looked for the 20th data value and the 21st data value, add up the two and divided by 2. And so if you're looking even further into these two values, then the 20th value on the list was 72, the last 72 among the repeated 72s. And the next, the 21st value was a value 76, which is the actual first value among all the repeated 76. We added up and we divided by 2. So now does this work right here look familiar with the work we have done finding the median back in data 1? So here in this demonstration, I was particularly looking at data 1 right here. And the value we've ended up was 74. So the way that we come up with these methods to find percentile, it's not the only way, but at least it's the way that fits perfectly into the convention how we found a median. And now you are well aware that the 50th percentile in any data is also known as the median of the data. Let's look at your 25th percentile that we have done in the earlier example. Our 25th percentile we have found earlier. 25th percentile, from where that cut is, 25% of data falling below that. But 25% in a daily language, it means we have 1/4 of the data falling below that cut. And so now we now going to have a new term right here. 25th percentile now is known as we call that, it's the first quartile. 1/4, the first quarter of data being below that. And so here we call that cut right here, in particular, the first quartile. The first quartile has the symbol Q1. And so all of a sudden we start looking at quartile, indicating we're dividing the data into separate quarters. So 25th percentile is understood as the first quartile. Then, looking back again at the 50th percentile, we did find out that it was also known as the median of any data. But now we also found out that the 50th percentile, think about at where the 50th percentile was found right there. Then 2/4 of data being below that cut there. So now we also have another legal name for that, another AKA for 50th percentile. It was AKA the median of the data, and now it is AKA further, the second quartile of the data. And second quartile has the symbol Q2. Now looking at the 75th percentile that we found. Then everybody can have a good, nice guess, and it should be the truth, that besides understanding this as the 75th percentile, you can see that there are 3/4 of data being below this cut. So now a legal other name for that, we can call the 75th percentile the third quartile, simply indicating that there are 3/4 of data being below that. Symbolically, the symbol for that is Q3. And then now there's a little further impact right here, but think about the Q4. We don't need to have a Q4. So now I can legally tell everybody, no Q4. Think about what's happened after the Q3 location. After Q3, after the cutting value being the 75th percentile, after that, what we have here is the remaining 25% of data above that cut. So for that reason, we don't need to have a Q4 value.